This question is asking us to calculate the expected rotation of a mixture of a molecule, given its specific literature rotation in the R enantiomer form and the ratio of the R to S enantiomers in this particular mixture. Our calculation for calculating this is going to be the percent enantiomeric excess is going to be equal to the observed rotation of the mixture divided by the literature rotation of the pure enantiomer times 100%. To do this, we need to know what the percent the enantiomeric excess is. And so our enantiomeric excess will be the 64% S enantiomer minus the 36% of the R enantiomer to give us an EE of 28%, favoring the S enantiomer. The fact that it favors the S enantiomer is important because our specific rotation, the literature rotation, is given as the R enantiomer. To calculate this percent EE then, our 28% enantiomeric excess is going to be equal to the observed rotation. That's what we're trying to calculate here. Divided by the literature rotation. The literature rotation is negative 11 degrees for the R enantiomer. For the S enantiomer, in which this one is enriched, the observed rotation is going to be positive 11 degrees times 100%. When we do these calculations and we solve for the observed rotation then will be equal to positive 3.08 degrees. This is what we expect for this particular mixture of this molecule.